Hi everyone, in this video we're going to go through the solutions of this homework sheet. I did say I was only going to focus on a few questions, but I'm going to do them all. So you can either listen or just fast forward to the ones that you need to listen to. Alright, so we've got a mix of exponential and log equations to solve. So we'll move quickly through them. If you need any further assistance, just ask me in person. Okay, so first up we've got an exponential equation. You need to understand your index laws. So what we've got here, our power is a non-unit fraction. So what I mean by that is our numerator is not 1, so we do have to split that, and we can just split it by 1/2 times -3. You can, and the order does matter, so if we were to do it to the power of 3 and then take the square root, you're going to end up with a really big number. So always think about which one's easier. So if we did, first of all, 9/25 to the power of 1/2, and then we took that to the power of -3. So and the AB is just there for the format of the answer. So sometimes in questions, it's just telling you the way that you need to structure your answer just to make it a little bit easier for marking, because as you should know, you can write answers multiple ways and they're all equivalent. All right, so to the power of 1/2 means we take the square root. So we take the square root of 9, which is 3, the square root of 25 is 5, and then we've got to the power of -3. I'm not going to worry about that A over B just yet, because that's just the format we need the answer. Now we've got two things going on here. We've got this negative power. That means we just take the reciprocal. So it's going to be 5/3 to the power of 1/3. And then we're going to cube both the numerator and the denominator. So 5 cubed is 125, 3 cubed is 27. So A is equal to 125 and B is equal to 27. All right, heading into question 2, so another exponential question. So we've got 3 to the power of 4n times 18 to the power of n plus 1 over 6 to the power of 3n minus 2 equals 3h plus 2k. Find expressions for h and k in terms of n. Now with this question, this 3 times 2 is a little hint about what we might need to do to simplify the left-hand side. I'm going to leave the 3 there, so to the power of 4n. Now the 18 and the 6, obviously we can't rewrite them with a base of 3 with a single power, like we could say 9 or 27, but I can rewrite that 18 as, and see how I've got these bases here, 3 and 2, so I could rewrite it as say 3 times 6, but I'm going to stick with those 3 and the 2, so 18 is the same as 3 times 3 times 2. All right, so the 3 times 3 is 9, 9 times 2 is 18. So I haven't actually changed it at all. And that's to the power of n plus 1. And then the 6 can become 3 times 2. So you should start seeing, okay, I've rewritten everything now in to a base of 3 and 2. Now when I expand everything, this power here, the n plus 1, is actually to the power of the 3, the 3 and the 2, and then this 3n minus 2 is to the power of 3 and this 2. So I'm just going to go and expand everything. So 3 to the power of 4n times 3 to the power of n plus 1 times 3 to the power of n plus 1 times 2 to the power of n plus 1, and then on the bottom we're going to have 3 to the power of 3 minus 2 times 2 to the power of 3n minus 2. Now don't go ahead and do 3 to the power of 4 because of the format our answer has to be in. So we're just leaving them with bases of 3 and 2. But because we do have these same bases, what I can do So we've got those 3s and we've got these 2s. It's really hard to see, so let me just change that maybe to a yellow. And we've got these 2, so we're going to just rewrite them. So we've just got a base of 3 and 2. All right, so my first 3, we've got to the power of 4n. So remember, when you're multiplying the same base, you add your powers. So we're going to have 4n plus n plus 1 plus n plus 1. And then we're dividing by a 3n minus 2. So I'm going to be subtracting that 3n minus 2. Now notice what I did then is I put it in brackets because you are subtracting that whole thing. And we don't want to make an error with this negative here. All right. So let's, we'll tidy that up in a second. So I don't need that down there, do I? Okay, times 2, and then we've got n to the power of plus 1, and again subtracting using brackets 3n minus 2. All right, let's tidy everything up. So I've got 4n, 5n, 6n, minus 3n gives me 3n. Just make sure I haven't missed anything, and then I've got 1 plus 1 minus negative 2, so it's going to be plus, so I've got plus 4, and then times 2 to the power of n minus 3n, so minus 2n, and then 1 minus negative 2, so we're going to have plus 3. So h and k are our powers, so h is equal to 3n plus 4, and k is equal to negative 2n plus 3. All right, so a bit of a tricky question, but you know your index laws. We're just using them. So often when you're doing, learning your index laws, you do them with different, bases that are not numbers, so pronumerals, and it makes a little bit more sense, but it's basically this, you were using the same index laws that you've learned since year 8, I think. All right, let's move on to question 3. Now, when you're simplifying log equations, always focus on what the base is. So we've got the same base here, which is super duper. And then this 8 over 3, just going to think about how I could approach that. I could separate my logs. Let's go ahead and do that. So I actually haven't done these questions yet. Sorry, I was just trying to recall my log laws. I am doing this correctly. Yeah, I haven't done these questions yet, so maybe a little bit tricky. All right, log base 2 of 8. So remember, whatever your base is, if you can try to rewrite your argument with the same base, and we'll put brackets around that. So we're going to have log base 2, and 8 can be rewritten as 2 to the power of 3. I can't change log base 2 of 3, and I can't change log base 2 of 12. Okay, I can't go ahead and actually I probably could go ahead and rewrite 12. Just thinking out loud. We could change it to 2 times 6. Okay, let's see how we go. So that cancels. We're left with 3 minus log base 2 of 3. And then we can separate this. So it would be log base 2 to 2 would be 1 plus log base 2 of 6. What do we got? 4. I'm just going to check and see if I'm on the right track. All right, I've just looked at the solution and I've done a completely different approach to what that question has done, but I'm going to keep going because I know I'm going to end up with the same answer. Okay, so we've got 3 plus 1, which is going to give us the 4. And then using my log laws, because I've got the same bases, log base 2 of 6. And because we're subtracting, we're going to be over 3. Oh no, I end up with 5, don't I? I've probably made a mistake there. Let me just double check. Oh, I know what I've done. I should have subtracted this whole thing. No, sorry, where am I? Oh no, plus. Alright, I did get the right answer. I was looking at the wrong question. Okay. So I was looking at C, see how C is if the answer is 1, and I'm like, how do you get 1? But then I wasn't really paying attention. So we've got 5 there. You can see the solution here is so much probably straightforward. I was using my log laws probably more than I needed to. So because we were adding logs of the same base, you could have just multiplied these like they've done in this solution. So 8 over 3 times 12, and that would give us yeah, so 32, and then changing that. So definitely much shorter using that one, and probably, you know, why I should look at the solutions. But you can see how I can get the same answer just using my log laws. And even though it took a little bit longer, there is nothing wrong with my method, but I do like the method of the other solution. All right, let's move on to B. So we've got log base 3 of 4 and log base 3 of 2. All right, so looking at my bases, we've got 3, so I can't actually cancel anything out, or nothing equals 1 or simplifies to 1. But I can see this 4. I'm going to rewrite that to the base, sorry, not base of 2, the argument 2 to the power of 2 over log base 3 of 2. And I'll move that 2 to the front. So then we get 2 log base 3 of 2. And then on the bottom we've got log base 3 of 2. So this is just a number. Log base 3 of 2 is just a number. So if you've got something on the top that's the same as the bottom, then they cancel out, or they equal 1, and we're left with 2 as your answer, which was quite a good one. All right. Oh, this one. Okay, so A was probably the easiest out of all of these. So this 4, we can just make the power here. So 2 to the power of 4. Now 2 to the power of 4 is 16. So we've got log 16 of 16, which is just 1. So a nice easy one to finish that page on. All right, so question 4. 3 log base 2 cubed root of x. All right, so when I read this, I'm just going to, sorry, my son's just got home and my dog doesn't realize that it's him, so he's just being a bit protective. All right, and remember, this is just the format of our answer, so we'll just leave that until the very end. Okay, so I've just rewritten the cubed root as 1/3. All right, I just had to pause because my son came in. So moving that 3 to the power. So then we've got log base 2 x of 3 on 3. So it just stays log base 2 of x. And then I'm going to just separate this part here. Actually, I could probably multiply. Oh no, sorry, not multiply, divide. Let's do that instead of separating them. All right, so we've got the same bases and we're subtracting. So we can do log base 2 of x on 3x. So our x's cancel. So we're left with log base 2 of 1/3. So that means our value of a is 1 and b is 3. All right, so we've got k to the power of n equals 8. Find log base 2 of k in terms of n. So let's just deal with this exponential equation first. All right, so if I want to get rid of base k, I can do log base k of both sides. And doing that, I'm left with n. Now the problem with that was a terrible k, sorry guys. The problem with that is our answer wants a base of 2. So this is where you can use your change of base. So we want to change the base to 2. So I've got log k of 8. Now when I'm changing the base, it's going to be a fraction. So we want to change the base to 2. So what I can just straight away do is log base 2 on the top and log base 2 on the bottom. Now your larger number goes on the top and your base goes on the bottom. So we're going to have 8 there and a k here. Now this 8 and this base tell me that I can simplify that. So I'm going to have log base 2 of 2 cubed and then log base 2 of k on the bottom. So that goes and we're left with 3 over log base 2 of k. And that is what n is equal to. Now we have to find log base 2 of k in terms of n. So basically I just need to rearrange that. So log base 2 of k is equal to 3 over n. All right, question 6. The solutions to the equation are x equals a, 1 over, find the value of a. So again, we just need to focus on this. All right, so all the other part is just telling us the format of the solution. So we just got to focus on log base 3 of x and 4 log base x of 3. So we do have different bases, so we're going to change that base. All right, so for this question, you'll notice there's 2 different ways in the solution you can do it. This first one, they've changed the base for both of them to e. And then the second method, so this side is your first method, this is another method, they've only changed the base of x to 3. So you can do either way. My initial attempt was going to be this way, so that's my preference, then because I'm just then not changing 2 logs, just 1. All right, so let's change 4 log base x of 3. Now before I do that, I do need to move this 4. So it's going to be log base x of 3 to the power of 4, which is 81. All right, so if I'm changing it to a base of 3, all right, so it's a fraction, the log whatever the base is, do it on the top and the bottom like that, and then the bigger number goes on the top and then the base goes on the bottom. All right, so we just changed that base. So now we've got, just putting back in our equation, so log base 3 of x is equal to, so instead of 4 log base x of 3, I can rewrite, put this in. Now that 3 and the 81, I'm just, I don't know whether to, let's do it. I'm just going to change that to 3 to the power of 4, and then log base 3 of x. So I'm just thinking where to go so they cancel. Whoops. And we're left with 1 over log base 3 of x. And what are we doing? We're solving for x. So I can take I can multiply both sides by log. So that's going to be log now this square is applying to the whole log, so just keep note of that. So if I want to get rid of that, I take the square root of 1, and when I'm taking the square root of 1, I must include the plus or the minus. All right, so I'm taking more space than I wanted to. So we've got, let's put that x onto the left-hand side, plus or minus 1. So to get rid of log base 3, we take 3 of both sides, base 3 of both sides, I should say. So x is going to be 3 to the power of 1, and x is going to be 3 to the power of negative 1, which is 1 over 3. So the value of a in this format is going to be 3. All right, just checked my answer and I noticed I made a boo-boo. So I didn't follow this 4 down. I wrote 1, so that should have been a 4 here, and a 4 here, and a 4 here. And so that means, just going to change these answers. So the square root of 4 is 2. So we're going to end up with 2 to the power of 1. No, sorry. What are we going to end up with? Change that power. Sorry, guys. 3 to the power of 2, which is 9. And 3 to the power of negative 2, which is 1 over 9. So your value of a is 9. So the error I made is let me just circle again, forgot to put the 4 here. All right, let's keep going. So question 7, another exponential equation. So making the bases the same, I could do 2, but I could also write 64 with a base of 4. So I don't need to change the 4 to a base of 2, which is good. 64 is the same as 4 to the power of, oh my gosh, oh no, maybe I can't. 4 to the power of 3. 4 times 4 is 16, 16 times 4. Okay, 4 to the power of 3. When your bases are the same, basically you're taking log base 4 of both sides. So we're just left with the powers. And so x is equal to 4. Nice, easy one. God, I'm such an idiot. Here I am saying it's an easy one, and I forgot this should have been to the negative 3 because it's 1 over 64. You're probably watching and like, why are you making so many mistakes? I'm sorry, I'm in a rush because I'm cooking dinner at the same time. Okay. Question 8. If the solution to 6,000 blah blah equals 12,000 if the solution is t, okay, find the values of u and t. So remember, it's just asking for the format of the question, so we're just going to focus on this part. All right, the 6,000. All right, so we've got 6,000 times e to the 0.05t is equal to 12,000. We can simplify that, not by adding an extra 0. So if we divide both sides by 6,000, we get 2 to e to the power of, oh my gosh. All right, so if we want to get rid of base e, we take log base e of both sides. And if we want to get rid of the 0.05, now 0.05 is, if you think of it in terms of fractions, which is probably a little bit easier to see, that is 5/100ths. All right, so the 5 is in the hundredths place, and that simplifies to 1 over 20. So what we can do is the reciprocal of 1 over 20 is 20 over 1. So if we multiply both sides by 20 over 1, which is just 20. All right, so u is equal to 20 and v is equal to 2. All right, moving on to question 9. All right, so whenever I see a question like this, it just screams quadratic to me. The only difference between this one and ones that you've done before are these powers. Usually we're just, our highest power is 2, but we can just say, all right, I'm going to just bring everything over to the right-hand side. So it's going to be minus 12. And we choose our favorite letter, so K for Kazaa, and e to the power of 2x. So there's nothing wrong with letting it equal something other than e to the power of x. If we let it equal e to the power of 2x, we're going to get e squared, not e, k squared, sorry guys, k squared minus 12. And then it's just a nice quadratic we can solve. All right, so two numbers that multiply to give us negative 12 and add to give negative 1. So we're going to have k minus 4 and k plus 3. So that means k is equal to 4, k is equal to negative 3, and then we've just got to see which one which solution holds for this. All right, so we've only solved for k, so now we've got to substitute back in e to the power of 2x. So take log base e of both sides, and then you can just do a half. All right, so there's one solution. That half being out the front also tells me we can take it as a power, so 4 to the power of a half. We should probably simplify it to log base e of 2. And then our other solution, e to the power of 2x equals negative 3. It doesn't exist because we can't take a log of a negative number. So our only solution is x equals log base e of 2. All right, heading on to question 10. So find the point of intersection of y equals e to the power of x and y equals 1 plus e to the negative x. So if your left-hand side is equal to each other, so obviously y equals y, then our right-hand side is equal to each other. All right, so all we do is say, all right, let's let e to the power of x equal 1 plus e to the negative x. Let's bring everything over to the left-hand side, and as I'm doing this, I'm thinking, yep, it's a quadratic, turning into a quadratic again. The only thing that you might question is this is not to a power of 2, so we can change it to be a power of 2 by multiplying everything by e to the power of x. Now doing that, and this isn't the first one you've done, and multiplying e to the power of x by 0 is still 0, so we don't really need to do it on the left-hand side. Let me just do that. But if we did, let's just put it in there anyway. All right, so multiplying everything through, that means our first term will be e to the power of 2x, which is awesome. Then we've got the base is e. When you're multiplying the same base, we add our powers, so x minus x is 0, and then we're left with minus 1 times e to the negative x. Anything to the power of 0 is 1, so I'm just going to rewrite this over here, quite small so we can fit everything in. I'm just going to put it in order power, just to make it a little bit easier. Now, what is annoying about this is it looks like I'm going to have to use the quadratic formula, which is so super duper annoying. All right, let's see our solution if they've done it. Okay, so you can see the use of the quadratic formula here. All right, so we might, just because we don't have much space, we might talk more to this. So let's just set it up first. So using your favorite letter K, they've used M. So we've got k squared minus k minus 1 equals 0. And then you'd use the quad formula. All right, so let's just go to the other solution, just because it's already done for us. So your value of a is the coefficient of, in this case, they've used m and not k, so is 1, b is negative 1, and c is negative 1. So substituting them into your quadratic formula, we end up with m, or k in what we did. What is that going to be? Oops. Oh, I don't like using this. It's so annoying. All right. Go back. All right. Well, it's going to be negative 1 plus or minus square root of 5 over 2. All right, let's just tidy that up. So 1 plus or minus root 5 over 2. So we have, because it's a quadratic, two possible solutions. M is equal to e to the power of x, so we can just go ahead and do both solutions. All right, so there's 1, and then the other one with your negative. All right, so taking log base e of both sides. Which is north, and what have they done? over here. Oh, it's a point of intersection. Okay, I was wondering why we've got two possible answers here. All right, and then on this side, now you might be thinking, how do I know if it's negative or not? All right, square root of 5. Let's have a look for a sec. Where does it fit between perfect squares? It's between the square root of 4 and the square root of 9. So it is somewhere between 2 and 3. So obviously if I'm doing 1 minus 2 point something, we're going to end up with a negative number. So x can't be equal to that. So x is equal to that, and then to get our y, all right, we can just substitute it into here. So e to the power of log base e 1 plus root 5 over 2. So obviously they cancel, and that's why we end up with a 1 plus root 5 over 2. So there's your answer there. All right, as a set of coordinates, because we're finding the point of intersection. So quite a tricky question. All right, let's go back here. All right, so now we're solving a log equation. So I'm just thinking as I'm doing it. All right, so if we want to get rid of base 10, sorry, log base 10, we take base 10 of both sides. Now, I'm never a big fan of decimals, so let's change that to a fraction, so negative. All right, so it's just going to be 1 over because of that negative, and then the half is just the square root, and we can't simplify it any further than that. All right, question 12. Let me scroll. All right, so we've got the same bases, which is good, and so we're adding them so we can multiply x plus 3 times x. Now just make sure we put brackets around that because that x is multiplying both. All right, so we've got x squared plus 3x equals 1. So if I take base 10 of both sides, it's going to get rid of that. So we're left with just x squared plus 3x, and then base 10 of the other side. So 10 to the power of 1 is just 10. And bring that 10 over, not as a plus, but a minus, silly Billy. All right, and now it should just be a quadratic we can solve. So two numbers that multiply to give you negative 10 and add to give you 3. So nice, nice one to do. So negative 2 times 5 is 10, negative 10, and negative 2 plus 5 is 3. So we don't have to use the quadratic formula. So x equals 2, x equals negative 5. But we do have to test our solution. So we've got to substitute it into here first. So clearly it can't be negative 5. So x can't be negative 5 because we can't take a log of a negative number. When we substitute 2 into here, it does work, and it obviously works for here as well. So that's your only possible solution. So always check your answers with your logs. All right, nearly there. Just take a sip of water. Okay, all right, let's just move that x to there, and because we're subtracting the same logs, let's do everything in one go. So log base a of k over k, oh, I don't know whether I'm making it easier if I do that. All right, let's just keep going. So that's k to the power of 1. So I can rewrite that as just k1 minus x. We're doing x in terms of y. Okay, so we need x equals. Let's take base a of both sides. All right, we need to get rid of the k. So to get rid of the k, we're taking log base k of both sides. And then we can just make that x a positive. So it's going to be 1 minus log k a to the power of y. We can bring that y out the front. So many letters, which gets a bit annoying. We can simplify it if we just want an answer in terms of log, but we can leave it with the 1 minus there. I might just check the answer. All right, so my answer looks slightly different, and on first inspection, I'm like, where did I go wrong? But then I noticed that I did a different base for my logs. All right, so see how I've got an A there? Sorry, they've got an A in their solution, and I had base K. So let's just, and it didn't tell me that I had to have the base A or K. So I'm going to just use change of base to show that they're actually equivalent. All right, so I'm just going to change log. So I'm just going to focus on this log base K of A. So if I'm not going to have enough space there. Oh, excuse me, I wanted the rubber. I might just do it in a different color so we can just differentiate, because I'm going to go quite close. So we want to change just this part here, log base K of A, and I'm changing the base to A. All right, and the reason I'm doing that is just to show you with the answer, this is the same as what the solution got here. Okay, so our answers are the same, it's just our bases are different, and both are perfectly fine, okay, because it didn't tell me the format I had to have my answer in, but I guess because the question had a base of A, there's a hint. And my working out is slightly different as well, but still gonna get the same answer. All right, so changing the base to A, and then this A goes on top, and then the K on the bottom, and we get 1 on the top, and log A, base A of K on the bottom. So just going back to our question, it's going to be x equals 1 minus. Now that y I kept separate, we only changed the base for the log, so the y is going to be multiplying this basically. So we're going to have the y on the top and log base A of K on the bottom. So same answer as the solutions, okay? I just wanted to show you that our original answer, which was this one here, is perfectly fine. All right. Didn't tell us what base we had to have, so both would be accepted. All right, question 14. Oh, so we've got log base 2 of 32. When I see that, I already think, oh, let's change that 32 to 2 to the power of 5. Okay, so it's telling us nk equals that. Find the values of a, b, and c. Why have they kept k separate? All right, let's just make an attempt. So log base 2 of 2 to the power of 5 equals k log base 2 of 9 plus 4. All right, so we're going to get 5 equals k log base 2, 9. Oh, it's just the format we want k in. Okay, I get you. All right, so we can subtract 4 from both sides. I'm going to just bring that k over. All right, so it's going to equal 1. And we want to get k on its own, so we can divide both sides by log base 2 of 9. So k is equal to 1 over log base 2 of 9. Now, just notice with our format, it wants this base to be the same as this. So because it's already 2, I can, and I want, so that 9 I can rewrite as 3 squared, and that's going to help us. So log base 2, instead of writing 9, we can have 3 squared, and then that power comes out the front. So 2 log base 2 of 3, bit squishy. So that means A is equal to 2 and B is equal to 3. So just as I've said before, they're just telling you this to get the format of the answer, because as you can see in the previous question, there are many ways, well, not many, but I had the answer in one way and the other solutions had it in a different way, but both perfectly fine. All right, lucky last question. All right, if f of x equals log base e of x minus 1, g of x equals f of x plus 1, and t of x equals f of x plus 1, find the point of intersection of g of x and t of x. All right, so let's get g of x first of all. So g of x is equal to f of x plus 1. So I'm going to take f of x, which is log base e, and wherever we see x, we're going to substitute in the x plus 1. So instead of that x, we're going to put x plus 1, and then we've still got that minus 1 there. Let's just tidy that up, because obviously those ones cancel each other out, and we get log base e of x. All right, now let's do t of x. So t of x is equal to f of x, x minus 1. So there's f of x, and then we're adding 1 onto the end. So slightly different in that placement of the plus 1. All right, so if we're finding the point of intersection, we let g of x equal t of x. Maybe the combination of g and t is chi. Anyway, can you tell it's getting a bit late? So log base e of x, and t of x is log base e of x minus 1 plus 1. Let's bring everything over to one side. Doesn't matter which way you go. And I'm going to bring that, leave that one, sorry, keep that, blah, 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 blah. Move that one as well. So everything's on one side. Okay, so bases are the same. Just wondering about that minus 1, whether we make that. Anyway, let's leave it for now. Log ex over x minus 1 minus 1 equals 0. So I might, now I'm not going to look at the solution, but 1 I can rewrite as log base e of e. Is that going to complicate things? I feel like it. Let's put that 1 back over to the other side. I'm going to keep it over to that side. All right. All right, so I'm going to get rid of this log base e by taking base e of both sides. All right, and then we've got x over x minus 1, which is a little bit annoying. So let's just multiply. So we get x equals e times x. So that's still to the power of 1. Remember, e is a number, just like pi, minus e. We don't have to keep writing to the power of 1. So we get x. Now I'm going to bring everything over, minus e x minus plus e. Alright, so we're just going to, remember we want to get x on its own. So if I took that out as a common factor, I'm going to be left with 1 minus e and then plus e. And I'm going to bring that e back over to the other side. So it's going to be negative e, and then divide both sides by 1 minus e. So negative e over 1 minus e. Now we could leave it like that, but it's probably a good idea to have your numerator as a positive. So if I might just show you, because we could leave it like that. If I took out a negative on the bottom, we would be left with negative e minus 1. So then those negatives will cancel out. So we're left with e over e minus 1. So a little bit tidier, but yeah, you could use either this or this format. Doesn't really matter. Same thing. All right, so that's what x is equal to. Remember, we're finding the point of intersection. So we just now got to go back, and we can substitute it in to either g of x or t of x, because it's the point of intersection between g of x and t of x. I reckon g of x looks slightly easier. So log base e of x, let's just go back down. So g of e over e minus 1 equals log base e of e over e minus 1. All right, so we can separate that using our log laws. So log base e of e minus log base e of e minus 1. So we end up with 1 minus log base e of e minus 1. And that is the y value of our point of intersection. All right, and I just checked the solutions and they kept it as this one here, which is probably a little bit nicer than separating it here. Sometimes I just always think of going a little step further. So our point of intersection is e over e minus 1. That was our x value here. And then g of x or y, whatever you want to call it. Either format is fine. Let's just stick with what we had originally. All right, makes it a little bit easier. All right, and there you go. Bye, girls.